Hi guys, so in this video we will be solving this problem sliding puzzle. Okay, so the problem says that we will be given a 2 cross 3 grid. Yeah, we will always be given a 2 cross 3 grid of some numbers 1 2 3 4 0 5. This is our initial state and we have to achieve a final state. Our final state is this 1 2 3 4 5 0. This is our final state. Okay, what we are allowed to do, previous, yeah, so what we are allowed to do is that we can swap the position of the 0 with the adjacent cells. Like if we are 0 is present over here, so 0 can be swapped with the adjacent cells like left, right, top and bottom cells. So if we swap the positions, we'll get something like this: 1 1 0 3 4 2 5. Other option could be 1 2 3 0 4 5 and so on. We can apply the swapping again. When we reached at this particular configuration, we can again swap the position of the 0, so we can move to some place like 0 1 3 4 2 5. This is one configuration we can attain. Another one could be we can swap 0 with the 3, so we will get like something like this: 1 3 0 4 2 5 and so on. We can perform this swapping of 0 and we have to attain this final configuration in the minimum number of swaps possible. Okay, so what we have to tell is the minimum number of swaps to attain the final configuration. So I guess the problem statement would have been clear to you guys till now. Now let's move on to the approach how we can solve this problem. Okay, so initially we were given, like, let's see the problem what we were given: 1 2 3 4 0 5. 1 2 3 4 0 5. So what we will do is that we will try all the possible swappings, like what we can do with the 0. So the options are what? I can swap with the left character. So what I will get: 1 2 3 0 4 and 5. Other option could be what? I can swap 0 with what? The top character. So what I will get: 1 0 3 4 2 and 5. Another option could be what? I can swap this 0 with the right character. So what I will get: 1 2 3 4 1 2 3 4 5 and 0. So initially when I was over here, I was at level 0, like I had not performed any swaps till now. Now at this particular location, I was like I could perform three particular swaps. Like I could perform swap with the top character or left character or the right character, but each time I will not be able to perform the three swaps. Like think of this particular case: if 0 would have been present over here, then I could swap only with the bottom character or the right character. So the number of swaps are different each time, like allowed swaps which are allowed will be different each time. So at this particular moment, 3 swaps were allowed, so I performed the 3 swaps, and these are the configurations which I got after performing 3 swaps. So now currently my level will increase by 1. 1 indicates what? I have performed 1 swap. Okay, now what I will check: this is my configuration. Is it same as my final, like the one desired configuration? If I check, no, these are not the same. So what does it mean? I will perform more swaps. Whatever the available options I have, I'll perform more swaps. So what I can do from over here, I can swap this 0 with this 4. What I will get: 1 2 3 4 0 5. Now if we look clearly, this and this is what? These represents both the same state. So what we are again going back to the initial state. So we need to maintain some visited kind of thing so that we do not get into the loop of doing the same task again and again. So we will make a visited array, or not array, we will make some visited thing which will help us to detect that we do not get back doing the same thing again and again. So we will not perform this particular swap. Okay, so our 0 I will not perform with the 4. We can perform swap with the top character. So if we perform the swap with the top character, what we will get? We will get something 0 0 1 2 3 4 and 5. This was the only one option available over here. Now if we look, now we move to the next configuration. We check it with the final configuration. Is it same? No, it is not same. So what we will do, we will again apply the configurations, means all the possible moves which we have currently. So this 0 can be swapped with the left character, right, and the bottom character. So if we let's do one by one. Let's do with the left first. So what we will get 0, 1, 3, 4, 2 and 5. Okay, this is one configuration. Another could be when we swap with the bottom character, but when we swap with the bottom character, we will get the same, or we will get back to the original state. What will happen is that we'll get the state 1, 2, 3, 4, 0 and 5, and this is same as the initial state, so we will not do this again. Okay, since we have already visited this state earlier in the past, so we will not get back to the same state. Okay, so we will not make this swap. And now 0, this 0 can be swapped with the right character. So what we will get 1, 1, 3, 0, 4, 2 and 5. This is another option. Now we move on to the next configuration. First we will check whether it is same as our final configuration. So if we check, yes, it is same as our final configuration. So what we will do, we will check the current level, the level at which we have got this particular configuration. So level equals to 1. Level equals to 1 indicates that we have performed one swapping to get this particular, means to get the final result. So our answer will be what? Answer will be equal to level. That is, we require only one swapping to reach to the final configuration, and that is true also. If we check over here, if we swap 0 and 5, what we will get? 1, 2, 3, 4, 5, 0, and it is our final configuration. Okay, so this is what we are going to do. So we will be applying the BFS over here. We will be applying all the possible moves which our zero index have, and we will generate the new configurations. In the new configurations, we will check if it is equal to our the final configuration. If it is, then we will simply return the level. Otherwise, we will generate the new configurations, and as we do in BFS, we will keep track of the configurations which we have already generated. Like we will maintain a visited kind of thing, so that we'll be able to keep track of the already generated states. Okay, so the idea would have been clear. Now let's see how are we means going to keep track of these visited states. Like this is the tricky part in this particular question. Like we can do something like this. We will store each configuration of this 2 cross 3 array. Like first time what we will got something like this 1, 0, 3, 4, 2, 5. We will maintain something like we will store multiple 2D arrays, and each time we will check whether we have already got such a configuration earlier in the past. But this is not a feasible or a very good option. Like we will not be doing this. What we will be doing is that we can store the configurations as strings. What do I mean by it? Let's me explain that. Let me index this. Okay, so what this is, what 0 index, 1 index, 0, 1, 2, 3, 4 and 5, and I will store my initial state as initial string. Okay, and my initial string will be what? Initial string will be 1, 2, 3, 4, 0, 5. Okay, now I will store my final string, that is my result, the final configuration which I desired as 1, 2, 3, 4, 5, 0. Okay, now I will simply check whether my current string generated is same as the final string or not. But like there is an issue in this. Like if we store the matrix, then we know that if we are at particular location, what are the possible moves. We know that we can go 1 unit upward, 1 unit downward, 1 unit left and 1 unit rightward directions, and we will check if it is a valid configuration. Then we will check, then we will simply swap. But how we will do this in if we store it in a string? So what we are going to do is that we will maintain a index array. Means we will store a two-dimensional array. Like if we are at index 0, index 0 means index 0 element can swap with what? Index 3 and index 1 element. Index 2 element, index 2, where is index 2? This is index 2. So this element can swap with what? Index 1 and index 5. Similarly, we can store it in an array. Like what we will do, we will make an two-dimensional array. We will make an array where we will store index 0 element can swap with what? Index 3 element and index 1 element. Okay, index 1 element can swap with index 0, index 2 and index 4. So index 0, index 2 and index 4. Index 2 element can swap with index 1 and index 5. Okay, index 3 element can swap with index 0 and index 4. So index 0, index 4. Index 4 element can swap with index 3 and index 5. Index 3 and index 5. And index 5 element can swap with index 4 and index 2. Index 4 and index 2. So we can use this array to find how to perform the swapping. Okay, So let's keep it side. It will be helpful to us. Let's re-verify it whether it is correct or not. Index 0 can swap with 3 and 1, correct. 1 can swap with 0, 2 and 4, that is correct. 2 can swap with 1 and 5, that is correct. 3 can swap with 0 and 4, that is correct. 4 can swap with 3, 5 and 1, that is 4 can swap with 3, 5 and 1. So 3, 5 and 1, and 5 can swap with 4 and 2. Okay, so this we can use for swapping, for performing the swap. This we can use. Okay, so now let's see how we will be performing this algorithm after once we, if we are storing it as string. Okay, so what we will do is that we will maintain an initial string. So we'll traverse this matrix and we'll maintain an initial string. So our initial string will be what? Initial string will be 1 2 3 4 0 5. We made an initial string. Our final string will be what? That is target string. Final or target string will be what? 1 2 3 4 5 0. So this is our desired string. So we know that we can swap the zero, means zero element. So I will find the index of the zero element. Index of zero element is what? Index of zero element is 0 1 2 3 4. Index is 4. So we will check in our array. If our index is 4, then which elements can we swap with? So this is for 0, this is for 1, this is for 2, this is for 3, and this is for 4. So if our index is 4, then we can swap with 3, 5 and 1. So let's do that. So if we swap with third element, what we will get? Let me write the index over here also. 0 1 2 3 4 and 5. 4 and 5. So we can swap with third element. So if we swap with third element, we will get what? 1 2 3 0 4 5. This is one configuration we will get. Another we can swap with fifth element. So what we will get? 1 2 3 4 5 0. Another one we can swap with first element. So we will get 1 0 3 4 2 5. Okay, now we will, so this was initially we were at level 1, that is we have not performed any swapping till now. Now we are at level 1, that is we have performed one swapping till now. Now one by one we will check the characters, means check the strings. If the string is already visited in past, like we will store a visited something, kind of visited something, and we will store that 1 2 3 4 0 5 is already visited in past. Now we will check 1 2 3 0 4 5, is it visited, not visited? So we will mark it as visited. Okay, so let's mark it over here only, that so it is visited. Now we will check it if it is equal to our target string 1 2 3 4 5 0. No, it is not equal to our target string. So what we will do, we will generate again the configurations from this string. So here 0 is at what? 0 1 2 3, third location. So if we are at third location, what are the possible moves? We can swap with 0 character and 4 character. So if we swap with 0 character, what we will get? 0 2 3 1 4 5. And if we swap with 4, then what we will get? If we swap with 4 0 1 2 3 4, we will get 1 2 3 4 0 and 5. Okay, and if we are seeing that this is already visited in past, so we will not visit this particular case. Okay, so let me erase this one. So we are not going to visit this one. Okay, so work is done for this particular string. Now we'll move on to the next string. Now we will check the position of 0. First we will mark it as visited, like if it is already, it was already visited in past. No, it was not visited, so mark it as visited. Okay, now let's check the position of 0 character. 0 is at index 1 2 3 0 1 2 3 4 5. So if we are at 5 4 and 2, we can swap with 0 1 2 3 4. This is for 5, we can swap with 4 and 2. So if we swap with fourth character, so what we will get? 1 2 3 4 0 5, and we are seeing that it is already visited, so we are not going to visit this state again. Okay, so let's erase this string. Another option which we can do is we can swap with the second character. So if we swap with the second character, what we will get? 1 2 0 4 5 3. Okay, so this particular state. Okay, so this is not visited in past, so we can keep it. Now let's move on to the next state. Is it visited already in past? No, it is not visited, so we will mark it as visited. Now we will check if it is equal to our target string. So if we check, yes, it is visited to our target string. So that means we have find the final configuration. And if we check current level, our current level is 1. So what does it means? It means that we require only one swapping to reach this particular state. So our answer will be 1. Okay. So now let's see what we have done. How we are going to means. I guess the algorithm would have been clear, but let's once again recapitulate it. So what we will do, we will first traverse the matrix and make initial string and final string. Initial string plus, we will make the initial string plus final string, and we will apply the BFS technique. Apply BFS and we will generate new strings one by one. Let's write that. We are going to apply BFS, generate new strings like the possible string, and we will check with the target element. If it is equals, then if equals, then we'll simply return the current level, whatever is our current level. If our BFS is exhausted, then finally we'll return -1, which indicates that this particular state cannot be reached. Okay, and we have how to apply BFS. I guess you guys already know what we do. For that, remove mark star add algorithm. I guess you guys already know. And for visited, maintaining the visited, we will convert into string. Okay, so I guess the algorithm would have been clear. So now let's try to code this problem and let's see how whether it is working properly or not. Okay, so now let's try to code this problem, sliding puzzle. Okay, so as discussed, we will start by first making our strings, initial strings and final target strings. So let's make b equal to new string builder. Okay, for integer I equal to 0, I is less than b over here dot length plus I, or integer j equals to 0, j is less than board of 0 dot length plus j. What we will do, s1 dot append board of I comma j. Okay, like if we want to remember our steps, what we were doing, like initially what first was our target was what, making our initial and target strings. After that, what we were doing, we are applying BFS on it, and each time we were checking that whether our element, whatever the removed element, if it is equals to target or not. If it is not equal to target, then we were discovering all options, like all available options, using what, using direction array, like using direction array. And if removed element was equal to target, what we were doing, we were simply returning the level. And if BFS got exhausted, what we were returning, -1, that this configuration is not possible. And we were using direction array, like what we were doing for that, this is 0 element, 1 element, like we were storing it in the form of string. So we were storing the directions where we can move from a current index. So if we were at 0, then we could move to what, index 1 and 3, and if we are at index 1, then we were moving to index 0 and 2, and so on. We were doing it. So we'll do it later. Now let's do it whatever we're doing. So let's also make our target string. So our initial string also. So our initial string will be what, string initial equal to string builder dot to string, here it is sb, string final, that is target string, will be what, 1 2 3 4 5 0. This is our final string. Now we will apply the BFS. So for BFS we will need a queue. So queue of string q equal to new linked list. We are using the interface. Okay, now in the queue we will add our initial string. Okay, we will maintain a variable level also equals to 0. Okay, we need a visited also. So for that, let's make a hash set of string, hs equal to new hash set. Okay, now as we do in queue, while queue dot size is greater than 0, what we will do, we will one by one remove the element. So string removed element equals to queue dot remove. We will check if this element, if removed element is equal to target, like what we were doing. If we were having a string like 1 2 3 4 0 5, so what we were doing initially, we were removing the element, we were storing it in string representation 1 2 3 4 0 5. We were checking it with the target 1 2 3 4 5 0, like if both of these are same, no, not same. So what we were doing, we were discovering all the possibilities, like we were swapping. I was swapping 0 with 4, 1 2 3 0 4 5, and in string representation it will be stored as 1 2 3 0 4 5. And second option was swapping with 2, so 1 2 3 sorry 1 0 3 4 2 5, and so on. I was discovering all the possibilities, but I was doing it in for string. We were doing it using these directions, so we needed these directions over here. So let's make those directions also, because we are using storing it in string form. So for one index, what were the directions? Like 4 0 and 2 were the directions. So 0 2 and 4 were the directions for 1. For 2 index, direction was 1 and 5. For 3 index, direction was 0 and 4. For 4th index, direction was 1 3 and 5, and for 5th index, direction was 4 and 2. So these were the directions which we were using. But first we were checking if removed element, if current element is target, then what we were simply returning the current level. Otherwise we were exploring the other options. So first let's make a variable index. Let's make a variable index to -1. It will help us to find the index of 0. Like if we have any string, if we got any string 1 2 3 4 1 4 3 0 5, what we were doing, we were finding the index of this 0. If this is 3, suppose for now like 4, then what we were doing, we were checking in this 4 direction array, like for 4th index, what are the possible options in which I can swap the characters. This is what we were doing. So we'll do the same over here. So for integer I equals to 0, I is less than removed element dot length length, what we will do, plus I. We will check if removed element dot character at I, if it is equals to 0, then what we will do, we will mark our index as I and we will break the loop. Okay, and here it will be there is a function remove dot eq equals, we cannot directly do it. Okay, then we'll return level. So we have find the index. Now we need to make the direction array as well. So let's make direction array, directions equals to something like this. Let's store these values. These are what, 1 comma 3 0 comma 2 comma 4 0 comma 2 comma 4. Another is what, 1 comma 5. Okay, then 0 comma 4. Okay, then 1 comma 3 comma 5. Okay, then 4 comma 2. Okay, so now let's name this array as integer array equals to directions of index. Okay, now we'll move in these directions and generate all the possible configurations. So for I equals to 0, I is less than array dot length plus I. What we will do, each time let's make a new string. New string is equal to, we will use a swap function, and we need to pass the index. It will not be s1, removed element, removed string, index of the 0th character and the character index at which we want to swap, that is array of I. Okay, after that we will check if our hash set already contains this new string, like if it is already visited, then we will skip this one. So we will write continue. Otherwise what we will do, we will mark it as visited, that is we will add it in our hash set. So hash set dot add new string, and we will also add it into our queue. So queue dot add new string. Okay, and yeah, one more thing, we do this work at each level. So okay, so we have to make a variable size also, integer size equals to queue dot size, and while size is greater than 0, we do this task. So this will be inside a while loop. since we were incrementing level, right? What if I was having a string 123450, what we were doing, we were finding all the configurations, level was 0, then we are moving on to the next level and we were incrementing level by 1. So for doing that we need to write it inside this while loop. Okay, so yeah, now let's continue with the code. So after this while loop, what we will do, we will increase our level each time, and finally if we have exhausted our BFS, that means we will return -1 over here. We need to write one more function, that is this swap function. So let's write this swap function and also public static swap. It will return a string. So let's write that also, swap. It will take string as argument, index I and index j, right? Inside it, let's make a new string builder. String builder sb equal to new string builder of s1. Okay, what we will do, s1 dot set, we need to character at I and s1 dot character at j. Okay, and it will be sb dot set character at I as character at j. Now we need to do the same task again, and we will set character I. Now we have swapped the characters. Finally we will return string builder dot to string. Okay, so I guess more or less we have done everything. Let's still check if we are missing on anything. So we have added the initial string, mark we need to mark the initial string also. So hash set dot add our initial string also over here. Direction set is fine. Let's try to run this code and see if it is working fine or if there are some errors. So it is giving us correct answer. Let's try to submit it and see if it is getting accepted or not. So it is passing, so it is a correct solution. So I hope you guys would have enjoyed the solution.